Good morning to all of you. Today we are going to start exercise 7.4, which is optional of chapter 7. First question is, determine the ratio in which the line 2x plus y minus 4 is equal to 0 divides the line segment joining the points A with the coordinate 2, minus 2 and B with the coordinate 3, 7. Here I have taken the line segment AB, and this is a line which is dividing AB at point P. Let the point P with the coordinates x1, y1 divides the line segment in k/1. I have taken the ratio k/1. Now the coordinates of the point P are, using the section formula, I can write the coordinates of P are 3k plus 2 by k plus 1, comma, the second coordinate is 7k minus 2 by k plus 1. This is the coordinates of the point P, which I have taken x1, y1. So the value of x1 is 3k plus 2 by k plus 1 and the value of y1 is 7k minus 2 by k plus 1. Now this point P lies on the line 2x plus y minus 4 is equal to 0. It means this point P satisfies the equation of the line. So we can write x1, y1 at the place of x and y. So I have put the value of x1, y1 here in the line 2 into 3k plus 2 by k plus 1 plus 7k minus 2 by k plus 1 minus 4 is equal to 0. I have taken LCM here. 3 to just 6k plus 4 plus 7k minus 2 and minus 4 with k plus 1, because in denominator there is 1. LCM is k plus 1, so it will be 4 into k plus 1. After solving, I am getting the value of k is 2 by 9. Therefore, the ratio is 2:9. Next example. Find a relation between x and y if the points x, y, 1, 2 and 7, 0 are collinear. Here the word collinear is, and we know that if the points are collinear, then the area of triangle is 0. Here I have taken 3 points A, B, C with their coordinates. And we know that for the collinear, the condition is area of triangle is equal to 0. I have written x1, y1, x2, y2, x3, y3 values. And here this is the formula for the area of the triangle, which I have taken as equal to 0. So by putting all the values and after solving, I am getting x plus 3y is equal to 7. This is the relation between x and y. Next example. Find the center of a circle passing through the points 6, minus 6, 3, minus 7 and 3, 3. Here I have made a circle and this circle is passing through the 3 points. I have named them A, B, C. I have taken O as a center of the circle and I have taken x, y as a coordinate of O. Let point O with the coordinates x, y and the points A, B, C are on the circle and O is the center. If O is the center, A, B, C are on the circle, it means OA, OB and OC, these three are radius. So OA is equal to OB is equal to OC. Here in this question, I am taking the concept of distance formula. Distance formula is x2 minus x1 whole square plus y2 minus y1 whole square under the root. With the help of the distance formula, I can find OA, OB and OC. And I will use OA is equal to OB and OB is equal to OC. Now, OA is equal to OB. So, by using distance formula, I have put all the values. And after solving, I am getting 3x plus y is equal to 7. It means y is equal to 7 minus 3x. Again I am taking OB is equal to OC, and by putting it in the distance formula, I am getting the result 20y is equal to minus 40. It means the value of y is minus 2. Now from 1, the equation was 7 minus 3x is equal to y, and we have value of y as minus 2. So from here we are getting the value of x is 3. So the coordinates of the point O are 3, minus 2. Next example. The two opposite vertices of a square are minus 1, 2 and 3, 2. Find the coordinates of the other vertices. Now this is a square, so I have made a square that is A, B, C, D, and here the two opposite vertices are given. So I have taken them as point B and D. Point B is 3, 2 and point D is minus 1, 2. And we have to find the other vertices. It means we have to find the vertices of A as well as C. I have taken vertices of A as x1, y1 and the vertices of C as x2, y2. To solve this question, I will use three concepts of square. First, I will use about the diagonals. It means we can say this is the point of intersection. If I am taking it as O, then this is the midpoint of AC as well as of DB. Second concept I will use, the sides of the square are equal. And the third concept I will use, this is a right angle triangle, so I will use Pythagoras property. We know that the diagonals of the square bisect each other, therefore O is the midpoint of DB as well as AC. Now O is midpoint of DB, so the coordinates of O are given by 1, 2 using D and B. Similarly, the coordinates of A are x1, y1 and C are x2, y2, and also O is the midpoint of AC, so the coordinates of O are given by x1 plus x2 by 2 and y1 plus y2 by 2. So we have two coordinates of O, 1 and 2, and x1 plus x2 by 2, y1 plus y2 by 2. It means both are equal. So first coordinate means x1 plus x2 by 2 is 1, and the second coordinate y1 plus y2 by 2 is 2. And from here I am getting one relation of x1 plus x2 is equal to 2, and the second relation of y1 plus y2 is equal to 4. We know that all the sides of a square are equal, so AB is equal to BC is equal to CD is equal to DA. Now AB is equal to AD, so by using distance formula, I have put all the values, and here I am getting the value of x1 is 1. And we know that x1 plus x2 is equal to 2, so x2 value is also 1. Now by using Pythagoras theorem, DB square is equal to DC square plus CB square. But DC is equal to BC because it is a square, so we can write BC as DC. So it will be equal to double of DC square. Again I am using here distance formula. By putting all the values, I am getting the value of y2. One is 0 and second is 4. Now y1 plus y2 is 4. If y2 is 0, then y1 is 4. If y2 is 4, then y1 is 0. And also we have already found the value of x1, x2 as 1, 1. So if x1 is 1, y1 is 4, the coordinate is 1, 4. If x2 is 1 and y2 is 0, then the coordinate is 1, 0. So the other coordinates are 1, 4 and 1, 0. If I am taking x1 as 1 and y1 as 0, then 1, 0, x2 as 1 and y2 as 4, then 1, 4. Again the same 1, 0 and 1, 4 I am getting. It means the other two coordinates are 1, 4 and 1, 0. Next example, the vertices of a triangle ABC are A with the coordinate 4, 6, B with the coordinate 1, 5 and C with the coordinate 7, 2. A line is drawn to intersect sides AB and AC at D and E respectively such that AD by AB and AE by AC is equal to 1 by 4. Calculate the area of triangle ADE and compare it with the area of triangle ABC. Now this is a triangle with the vertices A, B and C. D and E are the 2 points on AB and AC such that AD by AB and AE by AC is equal to 1 by 4. This is 4, so we can say DB is 3. Similarly here AC is 4, so we can say EC is 3. It means we can say that the point D and E are on the sides AB and AC such that they divides them in 1:3. Here also. Now D and E divides AB and AC in 1:3. Therefore, we can find the coordinate of D by using the section formula, and that I am getting 13 by 4 and 23 by 4. Similarly, I can find the coordinate of E, which are 19 by 4 and 20 by 4. And now we have to find the area of triangle ADE, as well as we have to find the area of triangle ABC. Now the formula for the area of triangle is 1 by 2 in bracket x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y2 minus y1. Now using these coordinates, I have found the area of triangle. I have put all the values in area of triangle, and I have found in the last it is 15 by 32 units square. Now the coordinates of triangle ABC 4,6, 1,5 and 7,2. Again, by putting all the values in the area of the triangle, I am getting 15 by 2 units square. Therefore, area of triangle ADE by area of triangle ABC, which was 15 by 32 upon 15 by 2, after cancel out 15, I am getting 1 by 16. So, the ratio is 1:16. Next example, let A with the coordinate 4,2, B with the coordinate 6,5 and C with the coordinate 1,4 be the vertices of the triangle ABC. The median from A meets BC at D. Find the coordinates of the point D. Now this is a triangle. From A median AD is drawn to the side BC. Now D is the midpoint of BC, so we can easily find the coordinates of point D using the coordinates of BC, which will be 6 plus 1 7 by 2, 5 plus 4 9 by 2. So the coordinates of D are 7 by 2 and 9 by 2. Next part, find the coordinates of the point P on AD such that AP ratio PD, which is equal to 2:1. Now this time the point P is on the median, and this point is dividing the line AD in the ratio 2:1. So we can easily find the coordinates of point P using A and D. Here point P is dividing AD in 2:1, so we can easily find coordinate of points P, which are 11 by 3, 11 by 3 by using the section formula. Next part, find the coordinates of the point of Q and R on the medians BE and CF respectively such that BQ ratio QE is equal to 2 by 1 and CR ratio RF is equal to 2 by 1. Now this is a triangle. This time BE is the median. It means E is the midpoint of AC. So easily we can find the coordinate of E, which are equal to 5 by 2 and 6 by 2 using the midpoint formula. Now Q is a point on BE which is dividing BE in the 2:1. So we can find the coordinate of Q, which after putting all the values in the section formula we are getting 11 by 3 and 11 by 3. Now this time CF is the median, it means F is the midpoint of AB. We can find the coordinate of F because it is a midpoint. So the coordinate of F are 10 by 2 and 7 by 2. Here R divides CF in 2:1. So the coordinates of R will be 11 by 3 and 11 by 3. Now what do you observe? We observe that P, Q and R are the same points because every time we are getting 11 by 3, 11 by 3 as a coordinate of P, Q and R. If A, x1, y1, B, x2, y2 and C, x3, y3 are the vertices of triangle ABC, find the coordinates of the centroid of the triangle. Now first of all, what is a centroid? Actually, centroid is the meeting point of the medians of a triangle. Here ABC is a triangle, AD, BE and CF. These three are medians of the triangle and their meeting point, I have taken it as P. This is called centroid and we have to find the coordinate of this centroid. Centroid is the meeting point of all the medians of a triangle. Let P is the centroid of triangle ABC and we know that the centroid divides the medians in 2:1. Here the point P divides AD in 2:1, starting from A, here 2, here 1. Now D is the midpoint of BC. See here, because of the median, this point D is the midpoint of BC. So the coordinates of D are x2 plus x3 by 2 and y2 plus y3 by 2. Now P is dividing AD in 2:1. So we can easily find the coordinate of point P using the section formula. Here 2 into x2 plus x3 by 2 plus 1 into x1 divide by 2 plus 1, and the second coordinate is 2 into y2 plus y3 by 2 plus 1 into y1 by 2 plus 1. After cutting this 2 and this 2, we are getting x2 plus x3 plus x1 by 3 and y2 plus y3 plus y1 by 3, or we can say x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Therefore the coordinates of the centroid are x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3.